Передав вам обом. Там в тебе є.
Okay, welcome to everybody. Today we will talk about healthy start, the importance of seeds inoculation, and possibilities and perspectives in this direction. So, as I already told, today we have a more narrow audience, and here we have partners from several European states, and we will be happy to share our experience in terms of of seeds inoculation with you. So just a brief introduction of the company, and that I will give a word to my colleagues who will tell you more about this topic. So the organizer of the webinar is a group of companies BTU-CENTER, who is producer of microbial and enzyme products for agriculture and two other industries, for medicine and oil industry. We have more than 60 products. Most of all are certified for organic agriculture. Products are represented in retail shops and as well as proposed to farmers. Company counts more than 400 employees, produces more than 10,000 tons of bioproducts per year, which are used on nearly 3 million hectares annually. And we calculate that use of our products allows agri companies to earn more than $200 million per year. So a group of companies includes production of bioproducts, Institute of Applied Biotechnologies, which role is research and development and studying of our products in various conditions. Besides that, there is a consultancy office with a team of agronomists, nearly 50 of them, who supports farmers in decision-making about biologicals, and office of international office who supports our international partners. And today we have actually one of its activities. We share the experience of our team with our colleagues abroad. So BTU-CENTER does a lot of trials, more than 1,000 field trials annually. Besides that, we do a lot of laboratory tests in our own laboratory and in scientific stations with whom we are partners. And actually also we do more than 50 scientific research. We cooperate with both largest companies like listed here, as well as with small farmers and organic and conventional. BTU-CENTER is the largest exporter of microbial products in Ukraine and one of the 25% largest manufacturers of bioproducts in the world. We are part of the IBMA Association of Biocontrol Manufacturers, and we cooperate with FIBL in terms of certification of our products in Europe. BTU-CENTER have two representative offices in Eastern Europe. It's Russia, and in European Union it's in Germany. And first product of BTU-CENTER, namely AzotoHelp, Rizoline, and Ecostern, are already registered in the EU. Today we will talk about possibilities of some of these products for seed treatment. So we are exporting to 15 countries. This list is increasing each year, and in a list of countries there are tests and trials of the products. I think every one of you knows that Europe now take a road to ecologization, and European Green Deal declares that Europe would like to be a first climate neutral continent by 2050, and numerous funds are issued to reach the important indicators in this direction. There is several directions to realize this policy. For us, important ones are from farm to fork. It's in agriculture, and actually, no, we understand that according to these policies, there are programs which are realized and in Europe, and in which we could take active participants. Till 2030, the EU takes a biodiversity strategy, which also have some important changes in the sphere of agriculture, uh, which we should take in mind. For example, there should be actions taken towards declining of risks for pollinators, and some of chemical pesticides and protectants of the seeds are already banned on the market, which means that farmers are looking for alternatives to that pesticides. The same to these risky chemical pesticides is planned to be reduced up to 50% in less than 10 years. Besides that, you know that Europe take the path to organic farming, and they declare that they would like to reach 25% of agricultural land under organic farming till 2030. It's also very, from the point of view of Ukraine, it's even some aggressive strategy, because to reach this strategy, really a lot of measures should be taken. You know that registration of biopesticides in Europe is quite not easy task, and which does not allow for every player on the market to be present on European market with these solutions. So I think that to allow farmers to be effective in organic farming in Europe, some actions should be taken to allow more players to propose the solutions to farmers. Besides that, very important point is reduction of use of fertilizers. And actually, there are also, on our previous webinar, we talk about what we can do with soil to improve its nutrient possibilities. And today we will talk about how we can improve seeds possibilities to take more from the soil, so that farmers also can have some economy on fertilizers. So now, coming closer to our today's topic, seed inoculation, I took some figures from Duncan Trimmer Analytics, and namely, they say that seed protection market is nearly $4 billion, and it grows nearly 10% per annum. And biologicals are now only from 5 to 10% of this market, but its growth rate is twice higher. Also, they declare that till the 2025, this figure should reach closer to 15%, up to 20%. And so this direction or segment of biological inoculants is developing, and there is a high demand for it. Actually, there is an interesting story in this analytics that development of seed treatment began in the 17th century, quite accidentally, that farmers find out that seeds which were which were broken to the sea and then have better germination properties, and it like put an idea that there could be some instruments to inoculate seeds with something which would improve its properties. Talking about biological seed treatment products, its development began nearly 100 years ago, began with rhizobium products. that is products for legumes, mainly for soybeans, which improve properties of these plants for nitrogen uptake. And important things about the market also mentioned in this analytics is that the chemical seed treatment market is quite monopolized. There are 4 largest players on this market who make nearly 80% of the market. So there is a very small place for other players in the market. And all chemical producers of products for seeds already have their own direction in biocontrol, and they start with what they have the better reach to the market, and this direction is maize. So it's quite difficult to work on the market of maize with biologicals, but still there are some other crops like soybean, wheat, cotton, some vegetables for which there are quite a wide choice of biologicals for seed inoculation, and we will talk today about some of them. So what is inoculation? It is a process of colonization of seed coat of seeds by beneficial microorganisms that influence its properties during growing. Bioinoculants could be specific or universal, and today we will talk about both categories. Specific are symbiotic microorganisms or some mycorrhizal fungi which are developed for specific crops. For example, soya have its own symbiotic microorganisms and which differs from peas and other crops. And universal ones are those which can be used which are quite universal, which can be used both on wheat or on soybeans. An example of such are products based on Bacillus subtilis, Trichoderma, and others. So today we will talk about the products for inoculation of legumes, about mycorrhiza products and their possibilities. We will talk about biostimulants and their possibilities to improve germination and yield of different crops. And we will also look on some biofungicide products and the specifics of their use in comparison to chemicals. So thank you for your attention, and now I will give a word to our senior microbiologist, Volodymyr. I think that some of you already have seen him in his show, Simply About Microbes. And so Volodymyr now will tell us about inoculants for legumes.
Hello, everybody. I'll start my presentation. Okay, let's speak about symbiotic inoculations for legumes. But before it, a few words about Dmitry presentation. He used terms biopesticides, but if speak about me as biologist, I don't like these terms because I think that biological is not pesticides, it's a living biocontrol agent, and this is really different to compare with chemical pesticides, and this is a very it's very important to understand that if we speak about bioproducts, it's not pollutant, it's not pesticides, it's just another way to control pathogens. Okay. If we speak about inoculants for legumes, BTU-CENTER produce a few types of it based on different strains. It has different forms. So the first of BTU inoculants, it's a Rizaline, which include protectant. With using this protectant, we can treat the seeds up to 7 days before sowing. So it's useful for long terms keeping the seeds before sowing. Rizaline consists of special type of symbiotic bacteria which specialize for any bean crops. Then another product is bioinoculant BTU-T. It's a solid form which based on peat. It consists with pretty high number of living bacteria in it, up to 2.5 billions per gram. And we have special types of bacteria for any crops too. And the third product is have special consist. It can carry the symbiotic bacteria like Bradyrhizobium japonicum, Rhizobium leguminosarum, Mesorhizobium, Chinorhizobium, or other which specialized for any bean crops. But except of this, it includes a special phosphorus mobilizing fungus Penicillium bilae. The total tire of this product is 2.5 billions per milliliter, but this another agent Penicillium bilae is going like a second part of this product. And we recommend to use liposome adhesive like a sticking agent and carrier agent for stick these living bacteria on the seeds and prevent them from dying during storaging. If we speak about Rizaline, it's one of the top product for soya. We use it for 600,000 of hectare of legumes, more than in 1,000 of agri companies. Its average additional yield on legumes is 0.25 tons per hectare, and it's not a new product. It has a 10 years history of effective presence. Rizaline, like another our products, could consist from different species of symbiotic bacteria, because we provide this product especially for any crops which our partners asking us. It could consist from Bradyrhizobium japonicum, which symbiotic for soya, or Rhizobium leguminosarum of different biovar like Vicia or Fazioli, which symbiotic for another legumes like genus Vicia or different varieties of beans. We have in our collection strains, different strains, which includes Mesorhizobium ciceri, which is related from chickpea, and Another strain is Rhizobium meliloti, which symbiotic to different genera like Medicago, Melilotus, and Trigonella. So we can produce these bioinoculants for different, even niche crops. And Penicillium bilae is a special fungi which isolated from Ukrainian soils, has a very high activity in dissolving phosphate bound. So it's very useful for soya or other beans to get not only nitrogen from air, but even phosphorus from soil by one treatment with one product. Methods of application of bioinoculants, it's a standard methods. The most useful is treatment of seeds in the day of sowing. We recommend to use 2-3 liters per tons or 2-3 kilograms per ton for liquid or solid products. But you can treat seeds on 5 till 7 days before sowing by using Rizoline with protectors or Rizoline with liposome adhesive. In this case, we recommend to use the same amount of bioinoculant, like 2-3 liters per tons and 1 liter per tons of liposome adhesive. The norms of biopreparations for niche beans will be different for different cultures, but as usual, we recommend to use bioinoculant underis in the rate of 1 till 3 liters per tons. And the second part of underis is a liquid form of Penicillium bilae in dosages of 25 milliliters per liter of preparation. And of course, you can treat the seeds with indicators during the sowing. It's very nice because you can use only 0.2 till 0.4 liters per hectare of inoculant for soya or other legumes. If we speak about different studies, we provide it on all crops, but it's very hard to find some farmers which grow in niche beans in Ukraine. So the most of studies we provide in with soybean, it's more than 100 of studies, and 89% of them was successful. Successful, it means that it was economically effective, and we find that our product is working and that our product gives some extra money to our partners. The average income in dollars per hectare was $98, and the maximum income was $368 per hectare. And average increasing of yield was 0.26 tons per hectare. It's soybeans, and the maximum increasing of yield was 0.97 tons per hectare. If we speak about peas, there was 4 studies of these inoculants, and 100% was successful. It's increasing the yield average for 0.27 tons per hectare, and the maximum yield increasing of yield was 0.62 tons, and it's gave income in dollars per hectare average $67.5, and maximum income was $155 per hectare. About kidney bean, we provide 5 studies and 100% was successful. It increasing the yield average in 0.24 tons per hectare, and maximum increasing was 0.57 tons per hectare. and it gives the income in dollars average $96 and maximum $228 per hectare. We have just one studies on lentil, and it was successful. It gives average, not average, it gives increase in yield 0.12 tons per hectare, and it was nice in money because it gives our partner $52.8 per hectare. And about chickpea, we provide 26 studies and 88% was successful. The average income was $108 and maximum income was $500 per hectare. And in yield, it was looks like average 0.27 tons per hectare of yield and maximum 1 ton 0.27. Another studies of Rizoline on different companies in Ukraine. We providing it many years, and it was very effective. The seed treatment is the most useful application method for using Rizoline. We provide in different rate of these products from 1 liters per hectare to 3 liters per hectare, and our increasing of yield was 0.25 tons per hectare till 0.67 tons per hectare in different companies. And about different, some more information about different tests. When Rizoline was used with liposome in 2018 in Khmelnytsky region in Ukraine, it provides a very nice effect. You can see on the photo that study part of the field was greener, darker, so this soya has more nitrogen and providing more active photosynthesis, and you can see on the photo that root system was larger with a bigger amount of nodules. In this study, our variant was Rizoline plus liposome in dosages 2 liters per tons, and chemical pesticides. And the control was a competitive inoculant, so control variant is not competitive variant was with inoculants too, but it demonstrate less efficacy. Another test provided in 2016 in Cherkasy region, it's a central Ukraine. There was 2 applications of biopreparations. Before soybean cultivation was used ground fix. It's a microbial fertilizer for soil in rate of 5 liters per hectare, and after that, during sowing, to roll was used Rizoline in norms 0.35 liters per hectare, and we get extra yield 0.62 tons per hectare. And as you can see on the photo, the root system of this soya was big with a large amount of nodules on it. Another test of Rizoline on peas with special strains for peas. was provided in Kiev region and in Kharkiv region. In Kiev region, we use 2 liters per tons of Rizoline in 3-4 days before sowing with chemical protectant like Maxim XL. There was not test that was just using our inoculants on whole field in 300 of hectare, and average yield was 3.5 tons per hectare. It's not a test because in this company, Agroboguslavshchina Eco, Rizoline is a part of standard scheme of soybean growing. Not soybean on peas growing. Another company, Maria in Kharkiv region, used Rizoline for peas in norm 2 kg per tons in day of sowing with chemical protectant Maxim Star. They have filled more than 4,000 hectare, and they get yield in 2.6 tons per hectare. Effectiveness of Rizoline on chickpea. We use Rizoline in norms 3 liters per ton and Liposam in norms 1.5 liters per ton with chemical protectant and on control in this company get 0.9 tons per hectare of chickpea, and we get extra yield 0.1 tons per hectare with using of Rizoline. There was a scientific study in Institute of Feed Research and Agriculture of Podillia of Ukrainian National Agriculture Academy. The crop was chickpeas, and there wasn't previous crop. There was a black fallow on this field. They use 1.7 liters per ton of underrees for this culture, and application rate of working solution was 8 liters per ton of seeds. And they measure in the number and mass of nodules and the structure of chickpea plants in the flowering phase. So in the phase of branching, there was average 24.8 nodules on the plant with 0.25 grams of these nodules, of every nodules. And on control, there wasn't any nodules. On budding stage, there was 39.2 nodules per plant with average mass 0.6 grams of one nodules, and there wasn't any nodules on control plants. On the full flowering stage, on control plants became first nodules in numbers of 0.2 per plant with weight 0.09 grams per one nodules, and on treated plants there was 43 nodules per plant with weight 0.70 gram per one nodules. And if we speak about the structure of plants, they saw that treated plants was much bigger and much better developed, because it's depends on the number of nodules and amount of nitrogen which these plants get from these nodules. So on the flowering phase, the number of leaves on control plants was 31.6, and on treated plants was 99.6. Mass of leaves per plant was 5.37, and on control plants, and 16.54 on treated plant. And number of flowers was 3.5 on control plants and 10.6 flowers on plants with underease. BTU-CENTER recommend complete technology for soya, and we can make complete technology for any other crops. We have specialists which providing this technology scheme. So we recommend to use first of all, we recommend to prepare your soils, because everything started from soil, and the first treatment is a ground fix in dosages average 8 liters per hectare, and it's needed for better feeding of plants. And Mico help in dosages 2 liters per hectare to decrease the problem with diseases, because this product Mico help could improve soil and stop diseases development in near the root system of the plant. The second treatment is a treatment of seeds, and we recommend to use organic balance in dosages 1 liter per ton of seeds, Mico help in dosages 2 liter per ton of seeds, and Rizoline in dosages 2 liter per ton of seeds with Enposam. It's a product looks like liposome based on bacterial polysaccharides, but it consists with living bacteria in it with a low rate, but it's a very active strain from our collection. The next stage is application on stage of 348 leaf. It's application on vegetate plant with organic balance in dosages 0.3 liter per hectares, phytohelp in dosages 0.8 liters per hectare, helprost boron in dosages 0.5 liters per hectare, and Enposam in dosages 0.25 liter per hectare. Organic balance and phytohelp, it's plant improving products which could activate growing processes, activate immune system of the plant. It's provided a lot of amino acids and phytohormones for plant. And helprost boron, it's a micronutrient which includes except of all boron, and it's very needed for soy in this stage. And the next application we recommend to provide on stage of budding with organic balance in dosages 0.5 liter per hectare and phytohelp in dosages 0.8 liter per hectare to for plant growth promoting and preventing of diseases on these plants. And we recommend to use micronutrients helprost boron and helprost soy. Helprost soy is a special micronutrient developed by BTU-CENTER for soya, and Enposam in dosages 0.25 liter per hectare. This technology is very useful for organic and widely spread in Ukraine in organic companies. This is example of complete technology from BTU-CENTER on soya. It was used in Kirovohrad region. It's central Ukraine. And this scheme grants 1.01 tons per hectare extra yield for soya. It's a very big extra yield for Ukraine. I don't know about all in other countries, but in Ukraine it's a very big extra yield for soya. And of course, it's very useful to know which chemical products you can use with bio products. We provide in a lot of tests of compatibility of pesticides with our bio products, because still there are a bigger amount of.
To jest jeszcze można mieszać.
Yeah, of course, you can combine bio products with chemical products, but not all of them. So we test every active agent of chemical products, how it compatible with our strains of living bacteria. And you can see this table. There are 10 there, which consist of tiram. It's very hard pesticides, and it's abandoned in Europe and maybe abandoned in Ukraine for a few last years, and it's not compatible with bio products at all. You can see that fludeoxanil and acetamiprid is not compatible with bio products at all too. But the most of chemical pesticides is compatible with bio products. Sometimes we recommend to use it with liposome or without of sticking agent. Sometimes we recommend to increase the dosages of bio products. It depends on the type of chemical pesticides, but as usual, we can include our products to standard scheme, which consists of chemical products for seed treatments. And of course, if you use bio products during the sowing to the row, you have no any problems with chemical protectors on the seeds. Another test of compatibility of bioinoculants with chemical pesticides. We provide in tests with herbicides, fungicidal agent, and you can see that most of them is compatible with Rizoline. Only with metamitron we have some problems, but you can use our sticking agent liposome, or you can just increase the dosages of Rizoline, and it's okay to use our bioinoculants with it. Thank you for your attention. I think you have some questions, but Dmitro will say you how we will answer for it right now or after conference, or maybe we prepare some answers and send it to you.
Okay, so thank you, Valdemar, for presentation about inoculants for legumes. And I think if anybody have any questions, please write them to the chat, and we will look whether we have a possibility to answer them now or send you answers after the meeting. So I would like to add also that Rizoline is one of the products already available on European market, and it is also FIBL listed, so we can work with it in your states. Now let's move on to the second topic. Second topic is possibilities of mycorrhization of seeds, why we need mycorrhiza, and what we can propose here. So I give a word to my colleague, Dmitry Chernenko, with this presentation.
Hello, I will tell you about such a phenomenon as mycorrhiza. how to use it, how is it useful for growing crops, and also about our practice of introducing the mycorrhizal forming preparation microfriend. Mycorrhiza is symbiosis or rather mutualism, a joint mutually beneficial existence of fungal mycelium with plant roots. During photosynthesis, carbohydrates accumulate in the roots of plants, which the plant shares with the fungus. In turn, the fungus colonizing the roots serves as an intermediary between the plant and the soil. The mycelium are able to increase of total absorbent surface volume.
Dima, I'm sorry, could you please turn on the presentation? Because we don't see it.
One second.
Okay, we see it.
Trophic effects. Providing food and water even in extreme condition. Hormonal regulatory function, controlling plant metabolism, communicative function, participation in the life of the soil plant microbiota system. There are 7 types of mycorrhiza in the nature. 98% of plant species that have an aerial part create a symbiosis with spores of mycorrhizal fungi. 80% of these plants species create endomycorrhiza with fungi of the glomeromycota division. How is it different from others? The main difference between endotrophic mycorrhiza is that the fungal hyphae penetrate into the cells of the root cortex through the pores without passing through the plasmalemma. On the surface of the root, mycorrhiza is poorly expressed. That is, the entire main part of the fungus is inside the root. Clusters of fungal gypha in the form of tendrils can form in the root cells. Gypha can branch outside the cell. These formations are called arbuscules. They are responsible for the exchange of fertilizer and water. The vesicles are responsible for the accumulation of these substances. I pay attention to endomycorrhiza because, firstly, it works with almost all types of cultivating plants that we grow, and secondly, the microfriend its preparation contains spores of the glomus fungus from the glomeromycota division. Mycofriend is a mycorrhizal preparation based on 2 strains of the glomus fungus. It also contains Trichoderma herzianum, Enterobacter, Bacillus subtilis, Pseudomonas, Streptomyces, Bacillus megatherium, and Bacillus mucilaginosus. And this composition allows for better mycorrhiza formation. We recommend using mycofriend for seed treatment at a rate from 1.5 to 5 liters per tons, or applying directly to the row when sown. or system info row. If you have such seeders with a rate from 0.2 to 0.3 liters per hectare. As for seedlings, we recommend treating the root system when you transplanting plants into soil. Mycorrhiza will ensure the creation of a good root system and improve plant nutrition, thereby increasing the stress resistance of plants. And more about microorganisms. Trichoderma harzianum fungi actively populate and contribute to the rapid decomposition of plants residues and also produce biologically active substances. Bacillus subtilis bacteria then can fix molecular nitrogen, mobilize phosphorus, produce enzymes. Bacillus megatherium produce various biologically active substances that stimulate the growth and development of plants. Bacillus mucilaginosus absorb nitrogen from the atmosphere and phosphorus and silicon from the corresponding minerals. Enterobacter, bacteria that can blend atmospheric nitrogen, improve plant phosphorus, produce photohormones and polymers. Pseudomonas fluorescens get into the soil type, inhibit the root system, siderophores, and growth stimulating substances. Our preparation MycoFriend entered the market in 2017, years ago. Now it is used on more than 130,000 hectares, and solid test and apply in 11 countries of the world. We have a base of experiments, more than 200 studies, from which 60 in scientific station. 81% of tests have a high economic effect. For instance, farmers who use MycoFriend is worth more than $100 in additional income per hectare. And effect from MycoFriend. As for sunflower, from 56 experiments, 73% were successful. The maximum income, $346 per hectare. The average income was $87 per hectare. The maximum increase in the yield was 1.8 tons per hectare, and the average increase in the yield 0.33 tons per hectare. As for corn, out of 53 experiments, 87% were successful. Maximum income $346 per hectare. I'm sorry, $420 per hectare. The average income was $111 per hectare. The maximum increase in the yield was 1 ton 60 68 tons per hectare. And the average increase in the yield 0.44 tons per hectare. As for legumes, out of 22 experiments, 82% were successful. Maximum income $400 per hectare. The average income was $105 per hectare. The maximum increase in the yield was 0.8 tons per hectare, and the average increase in the yield 0.21 tons per hectare. This slide shows some of the experiments on the effectiveness of the microfriend on sunflower. The results were selected from different regions of Ukraine with different climatic and soil conditions. The effect of using microfriend at a rate from 100 to 250 grams per hectare provided us to an increase in the yield from 0.1 to 0.39 tons per hectare. On this slide shows the effectiveness of microfriend in comparison with an analog mycorrhizal preparation and a preparation based on microorganisms. As you can see, microfriend provide a higher yield increase, and accordingly, its economic efficiency was higher. On this slide, you can see the formation of mycorrhiza on sunflower and corn when using the microfriend. The upper photos are with the preparation, and the lower photos are the roots without the mycorrhizal preparation. On this slide shows some of my experiments on corn. The results were selected from different. The results were selected from different regions of Ukraine that have different climatic and soil conditions. The effect of using microfriend at a rate from 100 to 250 grams per hectare provided us to increase in yield from 0.18 to 1.05 tons per hectare. For example, to use the 4 kilograms per ton of the microfriend provided an increase in the yield of more than 1 ton in compare with control, and more than 0.8 tons per hectare in compare with the preparation for seed treatments. To use of the microfriend on cereals at a rate from 1 to 2 kilograms or liter per tons provided us to an increase in yield from 0.1 to 1.28 tons per hectare. It shows that the preparation is effective under different soil condition, precipitation, and temperature, as well as pesticide load. In addition, of MicroFriend works on winter wheat and hemp. When you grow millet, then MicroFriend has a positive effect on the formation of the yield and this plant. 6 kilograms per tons of millet seeds provided us to an increase in yield by 0.24 tons per hectare. It can use to treat soybean seeds regardless of what kind of inoculant you use. When MicroFriend is applied at a rate of from 1 to 2 liters per hectare per ton, this provides an increase in yield on average 0.2 tons per hectare. This slide shows the result in the yield, which are increased 0.8 tons per hectare. It is not an uncommon instances when climate condition helps to accumulate the effect. As you can see, the works of preparation can be used without special equipment. The first options is directly in the field, and second options is of dishes with water. The preparation MicroFriend has proven itself when in the garden. This slide shows the effectiveness of MicroFriend in different types of growing hazelnut shoots. When using the preparation for the purpose, you can provide a larger number of high quality seedlings of fruit crops. For example of how the preparation works, photo of the root system from industrial plantings of blueberries. Rate 1 liters per hectare of MicroFriend. And a photo of the roots with and without preparation under a microscope. Another example of the preparation work on gooseberry. Control and MicroFriend on the right, photo taken by a microscope with a magnification of 160 times. And thank you for your attention. I will try to answer all your questions in the chat.
Okay, so thank you, Dmitro, for your presentation. Now I will ask Volodymyr to join us because we had some questions about inoculants too. I think, guys, it's time when you change places without camera. We had, first of all, coming back to mycorrhiza. Mycorrhiza is a topic in the industry which is like quite highlighted, and there are quite a lot of products based on it. There are products, quite expensive one with poor mycorrhizal spores, mainly produced in United States or in Israel or in some other states. And the difference between those products and ours is that we have a complex mycorrhizal products where besides mycorrhiza fungi, we have some supporting microorganisms, which improves action of the process of mycorrhization. So from the examples of trials, you could see that this combination is quite effective, and I also must say that our product is quite economic for farmers. So coming back to the question, we had one from actually what, sorry. We had one from Mr. Zvezdomir Jelev about the soil temperature to apply inoculums in legumes. Because it could be a problem for early season. And Pius Floris, thank you, already commented that normally bacteria are inactive in temperatures below 5 degrees, and they go into dormancy until the temperature are above 5 degrees, and mostly the functioning is about 20 degrees Celsius. So Volodymyr, could you comment this discussion about the effective temperatures of soil for use of inoculants?
I just sent to Mr. Pius because he answered pretty nice for this question. Yes, we recommend to use all microbial products with temperature higher than 5 degrees Celsius. The moment is that if the temperature will be low after sowing of the seeds, that this bacteria in the rhizosphere near the root system of the plant, even a very young root system, will be a little bit more defended from low temperature. And the one point why we recommend to use liposome or enposome, our sticking agents based on bacteria's polysaccharide, is that these products could defend living bacteria from low temperatures too. So it's not problem to use bioinoculants, BTU-CENTER bioinoculants, because I can be sure only about our products with
Such soil temperature?
With this soil temperature, and I mean with peas which sown early in season, it's normal to use it with bioinoculants too.
Okay. And also we had a question about mycorrhiza and about its possibility of use with hemp, sconophylloi. Volodymyr, do you heard some experiences about it?
No, as I remember, we have no such experience in Ukraine yet. We just start working with a few companies which grow in hemp, but we start last autumn with our plant residues destructors for hemp, and we have no experience with mycorrhiza, but it's really interesting, and I think we will plan something like this in the future.
Do you know, or maybe there are some limitations, maybe in the literature it's written that there are some limitations for use of mycorrhiza on that?
As I remember, there are no any limitation. We just need to study the efficacy of this combination.
Okay, so we had also a question from Tomasz from Poland about Mycofriend and its compatibility with Cruiser 350 FS. Do you know such chemical? Or...
I know this chemical, but I don't remember all compatibilities of our products. I need to look in my tables with the results.
So we will check after the meeting and send to Tomasz additionally. So let's move on to our next topic. And I must say that mycorrhiza is not the only instrument to improve the germination and nutrition properties of seeds. And also there are alternatives. Actually, usually they can even be cheaper, such as growth stimulants. And so let's move on to this topic. Please, Vladimir, tell us about possibilities of microbial biostimulants for seeds.
Yep, one moment, please. Okay, why to stimulate seedlings and what can microorganism offer to seeds? It's a very nice question because microorganisms offer everything which seeds needed during they starting growing and during all vegetation process. Because as usually plant likes when it grow in a healthy soil with a lot of bacteria and different types of bacteria and fungi in it. So BTU-CENTER produce a few products. Some of them is complex, some of them is based on one type of microorganisms. But all of these products has a pretty nice effect on all biochemical processes in the plant. The first of it is organic balance, is a biostimulant with nutrient effect. It's consists of 5 bacteria like Bacillus subtilis, Lactobacillus, Penibacillus polymixa, Azotobacter phlococcum, and Enterococcus. All of these bacteria, it's a natural soil bacteria, plant growth promotion bacteria, as you know these terms. Organic balance has a total titer not less than 1 billion colonial forming units per milliliters, and it's effective in dosages of 0.2 till 0.5 liters per hectare during vegetation, or 0.15 till 6 liter per tons of seeds. It depends on the cultures of the seeds sowing dosages. So how it works? First of all these bacteria provided a lot of amino acid, plant hormones, and vitamins, which has immunostimulant and adaptogenic effect in all phases of growth. And all these bacteria, when it grows in the rhizosphere near the root system of the plant, it provides a protective barrier for these plants and balancing the function of all mechanisms of plant life. And if we speak about nutrient, the most nutrients from the soil fall into the plant and digested only with the help of microorganisms. The plant itself didn't provide enough dosages of mineral fertilizing. The plant trying to do it, but as usual, plants needed some microbes helps in this question. And due to the action of plant hormones, amino acid, and vitamins in this product, and which will be produced by living bacteria in rhizosphere, these plants will get stronger root system and bigger vegetative organs. We provide a lot of testing of biostimulants too, and one of them was provided in Kirovograd scientific station of Ukrainian National Agrarian Academy in 2017. We provided on different crops like winter wheat, maize for grain, on soya, on buckwheat, and it was standard dosages for winter wheat, soya, and buckwheat. 1.5 liters per tons of seeds, and for corn we recommend 2 liters per tons of organic balance for seeds treatment. And as you can see on this slide, we get a pretty nice effect on all tested crops with extra yield of more than 0.3 tons per hectare on winter wheat, more than 0.5 extra yield on grain maize, 0.2 extra yield on soya, and 0.1 on buckwheat. We study organic balance in Russian too. We study the seed treatment in northern region of Russia on different culture like buckwheat and winter wheat. For buckwheat, we used 5 liters per ton of organic balance in this study. And for winter wheat, we used 1.5 liters per ton of organic balance. And as you can see on buckwheat, we get extra yield 0.4 tons per hectare. And on winter wheat, we get 0.5 tons extra yield in northern conditions. So it's pretty nice to speed up the plant's development. Another, our biostimulant, it's Azoto Help. You can use it for you can use it like a soil conditioner to improving nitrogen fixation in the soil, but also you can use it for stimulate of plants during vegetation, because Azotobacter chrococcum, which including to this product, is very effective producers of amino acids, organic acids, vitamins, and plant hormones. Azoto Help has 1 billion, no less than 1 billion colonial forming units in milliliters, and you can use it for pre-sowing treatment of seeds or tubers in dosages of 0.1 till 1.5 liters per tons. You can use it for root fertilizing in fertigation or rowing in dosages of 0.2 till 0.7 liters per hectare. And you can use it for foliar fertilizing by spraying on plants in dosages of 0.2 till 0.8 liters per hectare. Azoto Help have a lot of ways of influence on agrocyanosis and on plants of in this agrocyanosis. First of all, Azotobacter chrococcum could fix atmospheric nitrogen, and Azotobacter provided in one of the highest level of this fixation between all soil microorganisms. Another way is improving the absorption of nutrients by plants, thanks to organic acids which produced by Azotobacter chrococcum. Another way is increasing of seeds germination by producing of gibberellins in the preparation, and it's nature normal gibberellins produced by this bacteria. It's not a chemical producing plant hormones. Azoto Help could influence on root system development by presence of auxins produced by this bacteria. It could improve all plants' immunity due to the presence of vitamins of B groups in the preparation, and it increase plant resistance to stress factors due to the whole complex of biological substances which producing by these bacteria. The main point, the main point why I recommend to use bacterial-based biostimulators is that you get all these biological active components in liquid products, and you get the producers of these biological active products which will live near the plants and continue in producing all of these molecules during all vegetation period. Some trials of Azoto Help. The first of it is a study of efficiency on cauliflower. There was there was studied on two variant of cauliflower, like Robert and Goodman, and control variant was just the water, and two test variants. First of it is root soaking in dosages 1.5 milliliters of Azoto Help in 3 liters of water per 100 units of seedlings. And the next variant is a watering with 5 milliliters of Azoto Help diluted in 10 liters of water, and watering was 0.2 liters per one plant. And we get a yield without treatment like 18 tons per hectare of cauliflower. And on the variant with Robert, we get extra yield with soaking of the roots like 5.6 ton per hectare, and extra yield with watering like 4.1 tons per hectare. On the variant of Goodman cauliflower, we get normal yield 18.6 tons per hectare. It was bigger that Robert variant. And we get extra yield 1.6 ton per hectare with soaking of the roots, and 5.7 tons per hectare with watering of these plants with Azoto Help. Also, we studied the extra yield and marketability of products on cucumber fruits. This studies was provided by Uman National University of Horticulture in Ukraine. The variety was Nizhensky 12. It's a Ukrainian selected sort of cucumbers. So the control variant was without any treatments. The next variant was a seed treatment with 30 milliliters per kilogram of the seeds, and the growing method was no seedlings. We get 45.2 tons per hectare yields on control variants with marketability 88% of fruits, and we get bigger yield with seed treatments. It was 65 tons per hectare, and marketability was higher. It was 92.3% of the fruits. The next two variants was with using of seedlings, and the first type was seedlings treatment in cassettes with dosages 1 milliliter of azotohelp per square meters. And the next variant is a single vegetation treatment in dosages 0.5 liters per hectare. We saw that in the first variant with seedlings treatment, we get 57.4 tons per hectare of yield, and marketability of these fruits was 95.4%. And with single vegetation treatment, we get 58.9 tons of fruits with marketability of 96 and 7%. Another trial on eggplant. There was a control just water, and we tested different application methods of azotohelp. The first was soaking seeds in dosages 20 milliliters per kilogram. The next one was root system wetting with dosages 0.5 liters for 1,000 of pieces. And the last one was spraying the azotohelp in dosages 1 liter per hectare. We control different indicators like height of the plant, stem diameter, and other. So on the control variant, just with water, the average height of the plants was 55.1 centimeters. With soaking seeds, there was 56.4 centimeters. With root system wetting, height was 58.2 centimeters, and with spraying during vegetation, it was 59.3 centimeters. The stem diameter of the control plants was 0.95 centimeters. The plants which seeds was soaking before sowing, it the same 0.95 centimeters, and we get some better results with root system wetting and spraying. The stem diameter was 1.03, 1.08 centimeters. We also measured the number of leaves per plant, and on control variant it was 44.3. On variant with soaking seeds it was 47.7. In variant with root system wetting it was 49.5, and in variant with spraying it was 51.1 leaves per unit. Also, we measured leaf area in and on control variant it was 14.1 square meters per hectare, and on the variant with soaking seeds it was 14.9 square meters. On the plants with wetting root system it was 16 square meters, and on the spraying plants it was 16.4 square meters. Also, we measured marketability of fruits, and on the control variant it was 92.3%. On the soaking seeds, 93%. With wetting root system, it was 95.3%. And on the spraying variant, it was 97.1%. And the results, we get 2.2 tons per hectare extra yield on plants with soaking seeds, 4.8 tons per hectare extra yield on the variant with wetting root systems, and 4 tons per hectare extra yield on the variant which was sprayed with azote help. Then another biostimulant, it's liposome. Liposome is a very unique product because it was developed like a sticking agent, but we find a lot of another functions in this product. Liposome doesn't consist of living bacteria. It consists of specially modified exopolysaccharide. It's a complex of biopolymers with molecular weight of 10 millions to 100 millions. This polysaccharides produced by bacteria to improving their medium of living. Bacteria use these biopolymers to defend from low temperature, high temperature, low moisture level. It uses it to share some fertilizing between colonies of bacteria and another. In this, this biopolymers has a pretty nice effect on plant growth and plant development. We use liposome in different for different type of treatments, and it's every time it was pretty effective. Like some examples, we use liposome with fungicides on wheat. Liposome was added to standard farm technology, and we get efficiency like a plus 15%. We use liposomes with fungicides on barley, and farmer uses 30% less of fungicides with 0.3 liters per tons of liposome, and he get plus 8.5% of efficiency. We use liposome with micronutrients on sunflower. It was standard technology with 0.3 liters per ton of liposome, and we get plus 15% of efficiency in this scheme. And it was interesting that there wasn't any rains for 90 days in that region in that year. Thank you for your attention. The topic of biostimulants is very interesting and very big, and I think we need a few days to speak about this to get all information and share all information with you. Thank you.
Okay, so Vladimir, thank you for the presentation. Also, we have some questions to you. And one question is about no-till technology. And also I would like mention that just next week there will be a no-till conference, NT Lab, where Volodymyr will be one of the speakers. So we invite you if you would like to join that conference too, to listen to different topics about no-till technologies. So Volodymyr, the question to you is, if we practice no-till or mini-till, can we expect mycorrhiza to survive more than 1 year in field, or should it be applied every year?
Okay, mycorrhiza, it's a very teeny, maybe tidy microorganisms. Mycorrhiza needed living plant roots. So if you use real no-till with cover crops, you can expect that mycorrhiza will be still alive on your field during more than 1 year. But you need to understand that brassica and amaranthus could kill mycorrhiza on the field for 1 year. So you need to provide special scheme of using different crops and mycorrhizal products. But I can recommend to use for no-till technology. I recommend to use bioproducts in such scheme. You need to use it in normal dosages, recommended dosages for 2 or 3 years for good spreading these bacteria on the whole of the field. And then you can lower the dosages of used biopreparations to promote quickly development of the plants on the first stages, and to prevent the accumulating of pathogen microorganisms in the soil, just to keep in the high level of plant growth promotions rhizobacteria in the soil.
Thank you, Vladimir. Here is one another question concerning comparison of chemical phytohormones, maybe biostimulants, with biological phytohormones. I think that you will comment, right? That
yeah, okay. Chemical ones is nice instrument to get one quick effect. So you can use it in standard, in conventional farming to stop development of the plants or speed up development of the plants in one someday. With a very quick effect. Biological phytohormones can be in two variants. It could be in variant of pure phytohormones, get it from bacteria. So it will give you the same quick result, but it will be more healthy for plant, because it will be the natural phytohormones, not chemically produced. And the next type of biological stimulators, it's liquid products with living microorganisms and phytohormones in it. In this case, the effect will be a little bit slower, but you will get the effect of plant growth regulation during all vegetation period, because evolutionary bacteria could produce its plant hormones in rhizosphere and on the top of the leaves during all vegetation period, and regulate the plant development accordingly to the needs of plants in every stage of development. I hope you understand what I say.
Okay, so thank you, Vladimir, for your presentations and answers. I think that people are getting used to your voice and materials, because you're active participant in different presentations, and besides that, also, as I told, we invite you to look through our series of simply about microbes. And now I invite to the word next speaker, Natalia Voloshchuk, who will tell us about the importance of soil, of seeds to be healthy, importance of prevention of pathogens development on seeds, and about the possibilities of microorganisms to help organic farmers and conventional farmers to have healthy yield with good indicators. So Natalia, I give a word to you. Please turn on the microphone.
Hello, everybody. I will tell you about why we should have the healthy seeds and how the biofungicides can help us to get healthy seedlings and better yield. So, certain diseases are seed-borne and may have a detrimental effect on germination. So you can see that we can obtain the seedlings, but they are already affected with fungal pathogens. And also it is possible if we have a high level of seeds infection with pathogens, so we will not receive any seedling. Or if we will receive seedlings, they will carry the infection to the field, and this will be next effect on the during the vegetation period, and we will put the inoculum to the field, and we can observe the high level of disease development. So the seed-borne diseases, disease contamination could be on the surface of seeds. It is Tiletia, for example. It is known as stinking smut, Fusarium, Alternaria, Cladosporium, Aspergillus, Penicillium, Epicoccum, Mucor, and Rhizopus. We can find them on the surface of the seeds. Interior of the seeds, we can also find some pathogens such as Fusarium, Septoria, Perinophora, Ascochita, Phoma, Drechslera, and Ustilago. So this kind of fungi can penetrate into the upper layer of the seeds coat or on the scale to be inside. Such fungi as Fusarium and Alternaria, they can penetrate and survive in the endosperm of the seeds. And I would like to stop on the Ustilago. Ustilago tritice, for example, it is the agent of losing smut. It saves in the embryo. So it is very hard to get it and fight with this dangerous disease, plant disease that result in nothing, no yield. So all grain usually will be destroyed. For such diseases, it is recommended to use not biofungicide because only chemicals that can make the plant poison for this agent could be effective against this disease. So, but biofungicides can help us with other fungi such that we can find on the surface of seeds and interior on the upper layers of the seeds. So internal seed infection such as Septoria blotch, you can see here like dots, it is pycnids in which we can find pycnospores. Million pycnospores will produce this fungus on the seed and infection will be increasing. So another example is Bipolaris arachiniana. It is the leaf spot agent. Also, you can see the lesions of influence of this fungus on the seedlings. Next, very important disease agent is Fusarium, ear blight, and of course Fusarium root rot agents. On the seedlings, it could be like reduction of the roots and infection of the shoots of the seedling. And I would like to stop on this fungus because it has two forms. The first form, then which we can find into the at the germination of seeds, and during vegetation period it appears as root rots and Fusarium wilt of the plants. And next variant, it is when the infection is at the wax milk stage of ear formation, and at this time Conidia fusarium come on the ear, start to germinate, form mycelium that can cover all ear, and the mycelium penetrate into the young grain, and together with ripened grain come to the storage for the storage. And during the storage of grain we can find such nice pink grains, and its quality is not good because it is mycotoxins, that secondary metabolites that can contaminate such grain, and it is financial losses will be for such with such grain. So surface seed infection, for example, black point that is caused by Alternaria tenuissima, Alternaria alternata, and Epicoccum species, Cladosporium, Drexlera, Graminea can also be the agent of this disease. So you can see that black point, it means that the embryo become black color, and on this picture shows us how the fungus develop Alternaria, in this case, Alternaria develops on the seedlings, and we also see the lesions of its influence on the plants. Also root reduction, and here you can see that surface seed infection with Alternaria in the humid chamber, and before put inside of humid chamber, seeds were not disinfected, but here on the nutrient medium, seeds were disinfected, and we can see that the Alternaria can be found also isolated from the inside tissue of the grains. So next, representatives of surface seed infection, as I told, Epicoccum, also it is sooty mold agent, Cladosporium herbarum, and Aspergillus and Penicillium. It is green, yellow, black mold, and Penicillium mostly Penicillia are mostly known as green mold agents. For legume plants, for example, for soybean, the agents of plant disease that can be transmitted with seeds. It is Fusarium species, Ascochyta, Botrytis, Peronospora, Coletotrichum, and of course molds such as Penicillium and Aspergillus agents. Seeds are a source of plant disease agent. And it is, you should remember that 60% of all crop diseases transmit through seeds and soil. So how does seeds become infested? During the vegetation period, first of all, during the vegetation period that depend on climate condition, and that period cultivars resistant to the disease agents, soil cultivation, all plays a role in the seed infestation. So during vegetation period, the seeds could be infected with loose mud, Septoria blotch, Fusarium blight. Next way, it is during the harvest, especially stinking smut that is safe in sources that Tiletia caries form instead of grain in the ear. And when we harvest, so this source is crushed, and million spores come to the grain and could be carried with it. So again, Alternaria cladosporium, especially when before harvest period, it is rainy, cold weather and rainy, warm weather, when ear covered with black mycelium of this fungi. So next stage, during the storage, the seeds can be infected with Penicillia, Aspergillus, mucor, and fusariosis can appearance more during the storage period, especially if it is the moisture of grain is more than 13–14%. So also transmissions way of disease agents through the seeds could be as inert matter in the seeds. What does it mean? It means that some fungal pathogens, they can form some dormant stages such as sclerotia, black sclerotia. It is very important for sclerotinia fungi, Botrytis species, and of course ergot. Why it is also dangerous? Because each of the sclerotia can germinate with fruit bodies or stroma. Fruit bodies is characteristic for sclerotinia and Botrytis. Forms on these fruit bodies ascospores, million ascospores, also ergot sclerotia germinate with stroma, and there is fruit bodies peritaceae in this stroma, in which forms asci with ascospores that are initial source of initial primary infection in the field. Next way, it's spores on the surface of the seeds, as I told you about the stinking smut, the teleospores. For example, here you can see that the grain looks like dirty with such teleospores on the surface. Also, another species that I told about, which I told before, can survive on the surface of the seeds and transmitted with them. Next type, mycelium into the seeds. You can see here the mycelium Fusarium verticilloides come from inside or from the scales of the barley on the surface, start to develop and produce canidia to spreading. on the seedlings. So all information that I told we can describe as this schema that shows us the role of infested seeds, also plant debris on which some dormant overwintering stages safe during the winter period or cold period. But we will talk about the primary inoculum from the infested seeds that results in low canopy infections. What does it mean? It means that we will have the appearance and increasing of level of root rots diseases, basal stem rots diseases that form then secondary inoculum. It means if primary inoculum could be also not only conidia but ascospores, the secondary inoculum could be also from conidia that forms on the mycelium stages of the pathogens, and also the further development of dormant stage that they can help also to infect the plants. So at this stage, we can see that these losses or yield losses from diseases could be from 3 to 55%. It depends on disease agent, climate conditions, soil condition, cultivar. So further, the low canopy infections can give a further development to infection of the leaves, of the top leaves, infection of the head or grain. So everybody knows that if flag leaf in cereals will be affected, so it could bring up 50% of yield losses because of transpirations, photosynthesis. These processes will be destroyed by fungal development on the surface of this leaf. So infection of the head or grain, I told you about Fusarium head blight that could be in the rape milk stage, wax milk stage of the cereals, and of course quality loss. So infested seeds, it's one of the primary source of the infection, and therefore we should limit it and fight it with it and protect our seedlings with pathogens. So I would like to stop and give you some information how the biofungicide works in comparison with fungicide, chemical fungicides. So chemical fungicides, it is known they active during 10-25 days, can limit the disease development. But biofungicides that contain the living cells, living microorganisms, antagonistic toward fungal infection or plant diseases, they can live, multiply and work a longer period, and they will not pollute outside I'm sorry, outside environment, so they are friendly, eco-friendly. I'm sorry, and they have longer effect. Sorry. So from our biofungicides, we recommend it as treatment for seeds it's microhelp that contain such antagonistic fungi, Trichoderma harzianum and Trichoderma lignorum, as well as a set of spores of natural fungicidal bacteria. Bacillus subtilis, Enterobacter, and others. For example, Enterococcus. So it is quite dense and high level of colony forming units per milliliter, 1 billion. So, and these microbes together with Trichoderma can be very effective, better effective than alone at the alone application of each other from them, alone from them. So next biofungicides are phytocid and phytohelp. So they contain Bacillus subtilis, mostly cells and spores. Phytocid, it is 1 billion colony forming units per milliliter, and phytohelp is more dense, 4 billion colony forming units per milliliter. So they are also very effective. It is also effective microorganism that could be found in nature on the plants, can protect the plants and prepare plants to meeting with fungal pathogens or pathogens. Because they are able to induce the plant resistance, and they produce the phytohormones to better growth of seedling. So the methods for analyzing seed germination in infestation, as I told, that it could be humid chamber, also the sun, between the filter paper like rolls, and in the filter paper that will show us not only, we can see not only the in a seed infection, but also the level of germination, level of germination, emergence and germination of the seeds. So we have we did conduct some laboratory study and research how the components of our biopreparation works toward the plant pathogens. So you can see here is the control petri dish, and here with blocks of test cultures of plant pathogens such as Sclerotinia, Botrytis cinerea, Verticillium lateritium, Droshlera saraciniana, and the trial when these fungi have no chance to develop in the together when near is Trichoderma fungi.
Sorry to disturb you, but could you take some water, please, because your speaking is difficult.
Thank you. Sorry. So next, again, Alternaria alternata, Fusarium axisporum, Nigrospora ariza, Fusarium culmorum. So you can see that Trichoderma suppressed growth and development totally of these plant pathogens. So phytohealth activity here, you can see also that bacteria that are in this preparation stop development Drosera graminea, Verticillium lateritium, and Cladosporium herbarum. In comparison, also with like ethanol preparation, Amistar, chemical fungicide. So you can see that the biopreparation is the same effective against such disease agents. Next, also you can see that mycohealth bacterial components are very effective against from Alternaria alternata, black point agent. It can also be like leaf spots agent, Botrytis cinerea gray mold, Fusarium oxysporum, Fusarium wilt, Fusarium root rot, Fusicladium detriticum, fruit spots. And against all, this is control and trial variants. And here is the you can see how disease agents are sensitive to the microbe components of the biofungicide. And here in the on the grain that in the humid chamber in comparison with control, where we can see the development of Fusarium. Here also is you can see that in control we have high level infection infestation of seeds with Fusarium agent, and treatment seeds with mycohelp in dosage 3 liters per ton and phytohelp 2 liters per ton help us and make the situation much more better. So here is the seeds treated with biofungicides, fungicide mycohelp in roll of filter paper and in soil. Germination in soil under the soil conditions. So you can see that and analog preparation, biopreparation. So you can see in comparison with control that seedlings treated with not seedlings, grain treated with biofungicide looks much more better. So here is the efficacy of biological preparation, mycohelp and phytohelp against seed contamination with plant pathogens. So you can see if in control we had 59% infested and infested the seeds and developing of the diseases. It's significantly drop to 7 and 9% with biopesticide. And we can see also that the germination level increase much more in comparison with control. So next laboratory study against winter wheat pathogens that was conducted in the Institute of Agriculture of National Academy of Agrarian Sciences. So technical efficiency of our preparation was 87.7, 84.2% it is much more, it is enough good, because the disease development at this level was 7–9%. So seed treatment with biofungicides, winter and vernal or spring wheat, also showed us the effective action of our biopreparation against powdery mildew, fusarium blight, septoria ear blotch, root rots. It is under the field condition. So next laboratory experiment. If we have the same tendency, decreasing of pathogen development and increasing of grain emergence and germination emergency and germination. So another examples on the soybean that was conducted in 2017. So again, we have double decreasing of appearance of seed-borne pathogens and development of diseases, and again stimulation of germination in comparison with control seeds. So here I would like to stop to tell you how fast we should use the treated seeds. So if it is 1-day treatment, and the effectiveness will be, technical efficiency will be 81–83%, with myco-help and phyto-help accordingly. So it means that before sowing, directly before sowing, if it will be 14 days duration of storage, so you can see that the technical efficiency can decrease approximately by 10% in comparison with direct using of such treated seeds. And 20-day, it will be again 10% less than before. So you should remember that it is better to use to apply biofungicides with seeds as treatment before sowing, but nevertheless it could be effective if you will store these seeds, treated seeds. So field researches. Here is represented information in comparison with chemical fungicide and our products, biological products. So we can see that our technical efficiency, efficacy can be, it is enough, has enough high level in comparison with chemicals. So it is about 10–20%, depend on the biofungicide, could be less, but it is biological, so it is eco-friendly. It will work longer. It is better for plant. It will support plant for growth. Soil conditions, the microbes will work against pathogens. So next, myco-help against root rots. So disease development in control was 18.5%, and with biofungicide, mycohelp 2%. Spreading, if in control it was 66.7, with mycohelp 16.6%. Average for 2016-2018 showed the same tendency, that the biofungicide, the mycohelp, reduce the disease development and spreading. So next, results obtained from the Institute of Agriculture in 2018 showed us that against root rots, milky wax, at the stage of milky wax ripeness of the ear, development was much more reduced. Development and spreading of disease was reduced comparison with control, and at the harvesting stage it was also the same tendency. It's much more lower level development and spreading of diseases in the field. So, and we have the better germinability plus 21.5% in comparison with control. Thus, you can see that biofungicides, they have a little bit less effectiveness in comparison with chemical fungicides for seed treatment, but in any case, you should remember that the microbes from biopreparation, they continue to live, continue work, and help plant to grow, develop, and better for better formation of reproductive organs of plants. And again, that the development of diseases in control, septoria 7.8, ascochytosis 4.5, angular spotting of leaves 11.5. So here you can see that the biofungicide can suppress such important disease agents. Thank you for your attention, and please, if you have questions, I will try to answer.
Natalia, thank you for your presentation. Still, if anybody has a question, you can write it to the chat. But while I'm waiting, let's look what we have discussed today. So we discussed possibilities and direction and indicators, possibilities of biotechnologies on improving of indicators of the seeds. So we talked about the germination and biostimulants. We talked about mycorrhiza and improving of uptake by of nutrients by plants. We talked about inoculants and for legumes for improving of the yield and improving of nitrogen uptake by these plants. And the last but not the least, and for 100% not the less important topic, the bioprotection of seeds using the biocontrol products. So on this meeting today, we had people from 6 countries. I appreciate your presence on this webinar. For us, it is important to update each of our partners with fresh materials and presentations. So we will share with you the recording after this webinar, reporting to the question of Pius. and we look forward to hear your experiences during this and next seasons. And also, as I told, previous webinar was concerned about soil properties, about healthy soil. Today we talked about seeds, and nearly in a month we will continue our series of webinar with the topic of taking care about healthy plants during vegetation. So thank you once more for today's activeness. Thanks to the team for preparation of these materials, and looking forward to see you on our next meetings.
See you. Bye.
Thank you, and goodbye.
Thank you very much. It was a pleasure to listen, and we'll see you again, Dimitri. Thank you very much.
Thank you too.
All of you. Bye-bye.
Bye.